Okay, so in today's video, we'll be looking at quadratic factorization. I know there's a lot of different techniques out there for factorizing quadratic trinomials, but today I'm going to show my own method, and it's a method that works for monic quadratics and non-monic quadratics. So you don't have to, think about which method you're going to be using depending upon which question. This is a method that works for all types of questions. So let's start off with a simple example to see how we can factorize these quadratics. So I'll put in 1. So our first example is going to be x squared plus 4x plus 3. Now I know some students have some techniques where they can do this in their head. Now this is one of those questions that you could easily do in your head, but I'm going to show you a method that's fairly quick, and I also don't like to do these factorizations in my head just in case you make a mistake. So let's see how we can use my method. So what I do is I firstly multiply the coefficient of the x squared term with the constant term. So in this case, it would be 1 times 3. And now you don't have to worry about any of the signs. In this example, they're all positive, but for future examples, we don't have to worry about any of the signs. So 1 times 3 is just 3. And what we need to do is we need to use the factors of 3 to somehow make positive 4. So that is by adding or subtracting. So in this case, the only factors of 3 are actually just 3 and 1. And we know that 3 plus 1 is going to give us 4x. So what we can do is rewrite this as x squared plus 3x plus x plus 3. Okay, and what we've done is we've actually taken this middle term, this 4x term, and we've split it into two terms, so 3x plus x. And what this allows us to do is to actually create two pairs, okay? And if you've seen our factorizing pairs video, you'll know exactly what to do. So what we need to do is actually just factorize the two pairs, and we get x plus 3 plus 1, x plus 3. And we can see that these two are the same. Oh, forgot my equal signs. Okay, and we can write in x, we can write in just x plus 3 and x plus 1. Okay, so we factorized this one. Now let's take a look at another example. So that one was fairly straightforward. So let's have a look now at example 2. So we have x squared minus 3x minus 10. Okay, again we will multiply the coefficient of the x squared term with our constant. This time we have minus 10, but we don't need to do anything with the minuses. We'll just keep the signs positive. So in this case we have 1 times 10, which gives us 10, and we have to somehow use the factors of 10 to make minus 3. So we have 10 and 1 as one of the factors. This won't help us to make 3, but the other factors are 2 and 5. So I can see that if I have 2 negative 5 or negative 5 plus 2, this will both give me minus 3. So again, I'm using the factors of 10, adding or subtracting them to somehow make minus 3. And I found that if I have 2 minus 3, I'll have minus 3. So let's see what we can do with this. So we can have x squared. I can do plus 2x minus 5x minus 10. So again, what I'm doing is I'm taking this middle term, this 3x term, and splitting it up into two terms. Now the reason for this again is to make four terms or two pairs that I can factorize. So let's see how this is going to work out. So now I need to just factorize each of these pairs. It will give me x plus 2 minus 5x plus 2. Let me just scroll down a bit, and I can see, actually let me keep the question in view, and I can see that I've got the same thing within the brackets, so I can just factorize this fully to give me x plus 2, x minus 2, x minus 5. Okay, that was fairly straightforward. I think we'll all be reasonably comfortable with these two questions we've done so far. So these are just monic quadratic trinomials. Now what happens if we get into non-monics? Well, it's actually exactly the same thing. Ooh, pen. Got a bit of an issue here. Okay, so let's have a look at example 3. And the example is a non-monic, so we have 2x squared plus 7x plus 6. Now we're going to try to apply the same sort of methodology. So what I'm going to do is I'm going to multiply my coefficient of the x squared term. In this case, I actually have something. It's 2 with my constant term. So this gives me 12. So 2 times 6 is 12. Now I have to use the factors of 12 to somehow make 7. And I can easily see that if I have 3 and 4, which are factors of 12, I can add them to give me 7. So I can do 2x squared plus 4x plus 3x plus 6 equals. Now I like to put the term or the number first so that I can more easily factorize or factorize nicer. So in this case I put the 4x first. If I had put the 3x, I won't be able to factorize it nicely. It's just a little bit more satisfying to factorize this way. But again, I have my two pairs. And again, I've split my middle term 7x into into two terms. And you can see that this process was actually exactly the same, whether it was a monic quadratic trinomial or a non-monic quadratic trinomial. And what it means by monic is that the coefficient of x squared is just 1. So there's nothing with the x squared, so it's the same as having 1. And in this case, it's a 2, so non-monic, but the process was exactly the same. Okay, so now I just need to factorize these two pairs. So that gives me 2x, x plus 2. And then if I factorize out 3 from this pair, that gives me x plus 2. Okay, so I've realized I haven't really talked through the factorization of the pairs in too much detail. If you're a little bit stuck on that, just check out our video on factorizing pairs. Okay, now I can put these together. So I have x plus 2, then I have 2x plus 3. Okay, easy as that. So that was a third example. Now we have one more example. So this one is 6x squared minus 20x plus 14. Okay, so on first glance, this actually looks pretty hefty. What we'll have to do is multiply 6 and 14 together to try to work out some of the factors that might work to give us 20. But whenever you get presented with a question like this, where the numbers are a bit bigger, the first thing you should do is to see if you can actually factorize something out to make these numbers smaller and more manageable. So what I can see is that I can actually factorize out 2 from here. So if I factorize out 2, it leaves me with 3x squared minus 10x plus 7. So now these numbers are much more manageable. Okay, so let's apply the same rule as we have been doing. So we'll multiply the number with the x squared with a constant. Again, the signs don't matter. So in this case, we had a positive, so wasn't too much to worry about. But back to this example here where we had a negative. We don't have to worry about the fact that it's minus 10. We just take on the 10 by itself and figure out the signs later by adding and subtracting. But since this is a positive, we don't have to really worry. We don't need to in any case. But in this case, we have 3 times 7, which is 21. And using the factors of 21, I need to somehow make negative 10. So the factors that come to mind are just 3 and 7 that work to give us negative 10. But let's just think about some of the other factors. So we have 21 and 1. So this wouldn't work. And actually, these are all the factors that we've got. So sometimes you'll find yourself having 2 pairs that work. Or sometimes you could find yourself not being able to find the pairs. So all you have to do is try to factorize 21 and look for 2 factors that will actually give you the number that you're looking for. Now, it's important to note that in this method, we can't just pick any 2 random factors. Like, we couldn't really use like 3 and 1, for example. We have to use one of these pairs, either 1 and 21 or 3 and 7. So that's something that I didn't really emphasize at the beginning, but you have to factorize it into pairs, essentially looking for 2 pairs and multiply to give you 21, but we'll add or subtract to give you 10. So you can't just use any random factors. Okay, so the next step is to actually break this up. So the inside, so we have 3x squared, then I have minus 3x. So again, I'm going to put 3 here so I can easily factorize it, and then minus 7x plus 7. So again, you can see that I've used 3 and 7, which are factors of 21. They multiply to give 21. And I've added or subtracted them to make minus 10. So in this case, I've just subtracted them to give us minus 10x. Okay, now what I will do is I will factorize each of these pairs. So I'll take out 3x or 3x. And this will give me just x minus 1. And then I'll take out minus 7. Give me x minus 1. Okay, let me just scroll down a bit here. Can I keep the question in view? Nah, okay, I'll just scroll down. Okay, and this will give me 3x minus 7 and x minus 1. Now, the good thing about using this method, like where I factorize first, is that if the question tells you to fully factorize, this is actually fully factorized. There's nothing that you can further take out from these brackets. Whereas if we went from this stage here, this line here, and we didn't factorize our 2, we'll most likely have this 2 inside, so we'd have something like 6x minus 14, for example, or 2x minus 2. And in order to fully factorize it, we would have to factorize that 2. Okay, so we've looked at 4 examples so far, and that's all the examples we'll be looking at. But you can see that the process is very straightforward. All we do is we multiply the number with the x squared with the constant, ignoring any signs, and trying to use the factors from that to make or split up our middle term. Pretty straightforward. If you have a look through all of these 4 examples and you have a go yourself, you'll easily be able to factorize any of the trinomials you might get in your exams.